Hi, this is Giovanni Daprat speaking, and welcome to example 4. I hope you got a chance to look at the other examples and feel free to contact me in case you have any questions. This, ex- this, is, this example is quite interesting one because pressure data quality, as we can see from here, um, it has some, it's not, let's say, not a good quality, but we'll try to do our best to model it. So here the objectives are identify the reservoir model associated with the investigated wells drainage area and the determination of reservoir and well evaluation parameters, which is basically quite a common objective. Our reservoir and well data is shown here. We have initial pressure of 3,940, thickness 30 feet, well radius porosity. Vertical is well, it's a vertical well. I'm saying this because we will see later on that it seems according to flow regime identification, probably for those of you that already got experience on that, you can see here there is a trend like half slope negative trend, and we'll deal with that in a moment. Regarding fluid data, this is the specific gravity and API of the oil, and because it is a DST test, rates are measured from separators. Well, actually, rates are measured from separators, no matter if it is a DST. But in this case, just to make want to tell you that this is an exploratory well. Okay, this is the test history, our bottom hole pressures and rates. We're going to analyze two buildups, basically, and choose one as we will see later why. This is the initial buildup and the final buildup. Previous to that, there is no recording on pressure, and probably before that there is a cleaning period. Okay, when we go and do to the log-log diagnostic plots, which we apply to both buildups, you can see here an unexpected behavior, especially with the initial buildup. We're assuming that after the unit slope, uh, which is due to wellbore storage, pure wellbore storage, there is a transition, and eventually there is we're gonna reach radial flow. But we'll comment on that. Also, you can see here that the comparison, the trend is not, you should expect, unless there is a good reason, you should expect similar trend. Um, this is your final build-up. And regarding the radial flow regime, even though we can, as said before, one, if we use the classical way to visually identify it, we can go one cycle and a half, and radial flow should be here. And you may say, well, this is radial flow from the initial build-up, but this is not quite a common response or trend for changing or wellbore storage effect. Or for the final build-up, it should be uh, probably here. Okay, we in this case, we're going to use the final build-up for interpretation. So this is what we're going to do here is to identify our flow, the present flow regimes. And this is wellbore storage, probably the first flow regime which appears in any type of no matter even in a formation tester, if you analyze, there is a wellbore storage initially. Then we have this trend here, and if we calculate the slope, is minus one half. This slope is very characteristic or of spherical flow, let's say. Then if it is a spherical flow, then over here we may say, well, spherical flow, now we go to the radial flow. Is this the radial flow and then a transition to another radial flow, or this is something else, or is another type of flow regime, which is the main idea of what we're going to deal with this test. And later on, as you know, in the test, and we're talking about close to 100 hours, this effect here, it could be due to discontinuities or limits. It could be a constant pressure limit, could be if it is a buildup, could be that you reach a stabilized pressure if it is a seal boundary. So making a summary, the -1 slope, one half slope is indicative of spherical flow that is commonly associated to limited entry well completion. However, there is no physical information, let's say, that from drilling or from the perforation that the well has been perforated, not the whole formation. After spherical flow, radial flow regime should be expected. However, as shown by the pressure derivative, trend is to keep declining. So several simulations were run or were carried out trying to find the best pressure data match. Model selected to show here is a well with limited entry and completed in a composite reservoir. And also, in addition, we use the deconvolution method. So this, what we see here is the IPR, actually, for this well. And the results regarding the reservoir boundary, we use a radial composite reservoir with two parallel faults. And we got some permeability value of around 38 millidarcy. Because it's a composite reservoir, it says that at about 92 feet, there is a change in diffusivity. Mobility basically remains the same, but diffusivity changes. Okay, so these are values for the spherical flow, the anisotropy, and the spherical flow permeability. And these two limits, or let us say discontinuities, one to the south and the other one to the north, like, well, it could be east or west. It's very close to the well, especially this one here, and this constant pressure type of limit. We need to use also a time-dependent scheme in order to simulate the whole test history regarding the pressures. So this now is the results shown graphically. This is the pressure simulation of the final buildup. You can see here that reasonably fits very well the data. And if we go to the whole test history, we can also have a good match for the entire pressure test history. Now we also try to use the deconvolution method, and in this case, these are the results that we got. We have a similar, the match for the deconvolved pressure is as good as the match using the analysis from one event, which is the previous analysis. So here we got a skin, a partially a limited entry, and the thickness perforated interval should be 17 feet, and a geometrical skin of 491. So we also use the radial composite model, but the boundary is infinite. I mean, this is not two constant pressure faults, and remaining values are like 26, which is in the order of what you got from the analyzing only the buildup. There are differences here. here the mobility is not is half one compared to the mobility we got with analyzing the last buildup. So let's draw some conclusions here. We try to do our best apply interpretation method, and we end up with a limited entry well completed in a radial composite reservoir located in a two parallel constant pressure faults. This is, mathematically speaking, the best model that we got to simulate the data. However, the interpretation results should be questioned due to the poor pressure data quality. No consistency in pressure trends during the build-up periods is a good example. In addition, there is no physical evidence of limited entry well completion, although a similar effect could be caused by plug perforation. In this case, this is just words. If that is the case, one way to verify it is just to run a production logging tool, which has not been done here. So we don't know by true what we do know. We get, because of spherical flow, it was easy for us to match with a limited entry type of well completion. So we did carry out the test interpretation, but the derived results should be considered qualitative or probably wrong. This is the thing here is that there are many factors here. One of the factors which is not covered here, but we do know from geology or seismic that there are no pressure support, like in the model. I mean, this is supposed to have one fault here, a constant pressure fault, and another constant pressure fault, which probably should be a good huge aquifer, which is not evident from the models. And also, a radial composite reservoir is assuming that from at this point here, which is about 90 feet, there is a change in mobility or diffusivity. Hard to visit, hard to accept or hard to verify. But this is a mathematical interpretation. As such, I did my best to do it. And so, but I probably is a good example of something that is not, it can be questioned. And this is what is a vertical limited entry well. What we're saying here that this is not according to the perforating log, let's say, all the interval, 30 feet, has been perforated. So why still we have a limited entry? Okay, you may have that probably these parts here, even though they are perforated, or the whole thing, some of the perforators are plugged, assuming, of course, a good cement and many of these. So this is open to, if you like to discuss more about this example, you can contact me. I can show you the data. We can share the data and play with the software more. Other interesting thing, probably I said it, the deconvolution results are not consistent with the buildup, the analysis made using the buildup event. This is also a feeling of that we, as I said, we did the best we could, but this is an example of something that is not, we cannot say the high resolution or uncertainties low in this interpretation. Okay, I thank you very much for your time, and please feel free, sorry, thank you very much for your time, and please feel free to comment, if you have any comments, to contact me via WhatsApp or email, and I expect you in example 5. See you.